So like I said, when you are balancing in a basic solution, you can add those OH minus ions at pretty much any time after you've added the H plus, as long as you're following the rules of whatever you do to the left, you also need to do to the right. So what we're going to do is take all of these three redox reactions that we've already balanced in acidic solutions, and we're going to convert them to basic solution. And we don't need to start over to do that, because we can build off of what we've already done. So to balance this in a basic solution, I'm gonna rewrite and do what we need to do all together. What we need to do is add OH minus to go along with the H pluses. So this has got 14 H plus on the left. That means I need to add 14 OH minuses. And I need to make sure that I'm adding the OH minuses to both sides. If I don't put 14 OH minuses on the right-hand side, this equation would no longer be balanced. So whatever I do with the OH minus, it's got to be the same on both the left and the right. 6Fe3 plus and 2Cr3 plus and 7H2O. Now the H plus and the OH minus, that's going to cancel out as 14 H2Os. H plus plus OH minus makes water. So 14 H2Os. And because we've done that, now we have these water molecules that we can actually simplify. We can take 7 water molecules from each side of the equation. So that's just going to leave us with 7 water molecules on the right. And in basic solution, 6Fe2 plus Cr2O7 2 minus 7H2O 14 OH minus 6Fe3 plus and 2Cr3 plus. And we could go through and check. This thing is still going to be mass balanced, 6 iron on the left, 6 iron on the right, 2 chromium, 2 chromium. 7 plus 7 is 14 oxygen, 14 oxygen, 14 hydrogen, 14 hydrogen. What about the charge? This looks like on the left-hand side we have a plus 12 right here, and then a minus 2. So the left side is a plus 10. And over on the right-hand side we have a minus 14. We have a plus 18 and a plus 6. It's plus 10. It's beautiful. Oh my gosh. Whew. Makes me all goosebumpy. So let's do that. Let's do that again. So we're going to do this one as well. And we don't need to start over. We can pick up from the acidic half reaction. So when I'm looking at the acidic half reaction right there, 6H plus, that's our problem. Since we have 6H pluses, we need to add 6 OH minuses to both the left and right sides. Ce4 plus, here I'm going to squeeze in the OH minus. 6 OH minus going to the left, and CO2, 6H plus, and my 6 OH minuses that are going onto the right side, plus 6 Ce3 plus. H plus plus OH minus is going to make water, so we have 6 H2Os. And usually when we do this with a basic solution, when we make water, usually we're going to need to simplify. So looking over on the left-hand side, I've got 1 water molecule on the right. That means I can take 1 water molecule away from both the left side and the right side. And that's all that we can do in terms of simplifying this one. CH3OH plus 6 Ce4 plus 6 OH minus makes CO2 plus 5 H2O plus 6 Ce3 plus. Wonderful. And we have 1 more. I wish we had a million more. So here is our H plus. There's 2 of them. That means we're going to want to put 2 OH minuses onto each side. 3 PO3 3 minus plus 2 MnO4 minus plus 2H plus plus 2OH minus. On the right side, 2OH minus again. You want to keep this thing balanced. 3-phosphate, PO43 minus, 2MnO2, and an H2O. The 2H plus and the 2OH minus make 2H2O. See if you can cancel water out. You've got 1 on the left, so we can take 1 away from both the left and the right, and there is that redox reaction, all balanced.